Okay, today I'm going to be solving the Cambridge University Engineering Admissions Assessment. This is an hour and 20-minute paper. It's multiple choice. It's made up of two parts, Part A and Part B. Part B is a bit harder than Part A, but there's not really a lot in it. You're not allowed a calculator on this exam, so I'm going to be solving a lot of the maths on the page. Okay, so look, first question. Okay, so this is a inequality. I prefer to move my x minus 2 to the other side instead of dividing by -1. So if you divide by -1, you've got to take into account that the sign of the inequality is going to change. So less than will turn into greater than. So I've just moved the x minus 2 over to the other side. Now I'm going to add 8 to both sides. Okay. So that becomes 14. And lastly, I'll multiply by 2, so it'll be x is less than 28. Okay, not too bad. Quite a simple first question. Okay, so we've got a nucleotide of lead that is changing by radioactive decay into another nucleotide of lead. And it asks what combination of emissions produces this change. So I can see that this top number, the mass number, has gone down by 4. Now, the mass number only changes if you have an alpha decay, and each alpha particle actually has a mass number of 4, and it has a proton number of 2. So you can actually work out that there must have been one alpha decay. None of the other radioactive decays reduce the mass number. Alpha is the only one that reduces it. It can't go back up again, so it must be just the one alpha, and that's the only option here with one alpha. The reason why it's 2 beta decays is because this would also reduce the proton number to 80, right? It would take away 2 protons from the nucleus. So you need 2 beta decays to raise this number by 2 again, because each beta decay is actually a neutron decaying to a proton and emitting a high-speed electron, which is a beta particle. Okay, so the answer is D. Moving on, which of the following is a simplification of this expansion? So we need to square these brackets. So if I square the first term, I'm going to get root 3 squared, which is just 3. Then I'm going to get root 3 times minus root 2, and then a minus root 2 times a root 3. So that is going to give me a minus 2 root 3 root 2. Okay, and then on the end, I'm going to have a minus root 2 times a minus root 2, which gives me just the square of root 2. So root 2 squared is just 2, root 3 squared is just 3, so we've got 5 minus 2 root 3 root 2, and that is option B. Okay. Right, question 4. We have a graph that shows a quantity y against a quantity x. We're not supposed to know what they are yet, but we can see that there's a gradient of 5 on this graph. You can work this out by doing change in y over change in x. So in this case, that would be 10 over 2, which is equal to 5. Okay, so we've got two quantities that are proportional to each other, directly proportional, and the constant is 5. So which of the following could represent this graph? Well, kinetic energy against velocity, it definitely isn't that one, because if I use the formula for kinetic energy, mv squared divided by 2, I can see that it's actually proportional to v squared. So it's not proportional to v, it's proportional to v squared. It wouldn't even be a straight line. Okay, so it's not 1. Option 2, potential energy against height for an object of mass 20 kilograms being lifted by a constant external force. So we need to use the equation for gravitational potential energy here. So G, P, E is equal to mgh. Okay, so we need to work out what this constant mg is, or the weight. The weight in this case will be 20 kilograms multiplied by the gravitational field strength, which is taken as 10 in all of these questions. So it's going to be 200 here, which means that it can't possibly be option 2 because that should have a gradient of 200. We only have a gradient of 5. So 2 is out. Option 3, a velocity time graph for an object of mass 20 kilograms being accelerated by a resultant force of 100 newtons. So you should be aware that a velocity time graph, the gradient on a velocity time graph, is actually the acceleration. So you can work that out by just using change in velocity over change in time. That is just the same as our change in y over change in x, but with y being the velocity and x being the time on this graph. So this is actually the definition of acceleration, the change in velocity over the change in time. So in our question, we need to work out the acceleration. If that acceleration is equal to 5, then we've got a gradient of 5 and this graph would work. So we're going to use the equation F equals ma. So our total resultant force is actually 100 newtons and our mass is 20 kilograms. So if we use A equals F over m, we will get 100 over 20, which is in fact 5. So this option is correct. And actually, if you look now, you don't have to even look at 4 if you don't want to, because there's only one option left that uses 3 but does not use any of the ones we've proven to be false here. So the option F is the only option left. Just to be clear, just to be sure as well, we should try option 4 just to make sure that we're correct. So the work done by an external force of 5 newtons against the distance moved for an object of mass 12 kilograms. So we're going to be using the work equals force times distance equation. So this is directly proportional. Work is directly proportional to the distance moved, and the force is 5 newtons, so this is a gradient of 5, so that would work. The 12 kilograms there is actually not necessary. You don't need to use that. It's a bit of a red herring there. You can just ignore that. Okay, moving on. The ratio of Q to R is 5 to 2. The ratio of R to S is 3 to 10. Which one of the following gives the ratio of Q to S in its simplest form? So whenever I get a ratio question like this, I prefer to write it as a fraction. So we can write it as a fraction. Q over R is equal to 5 over 2. And R to S we can likewise write as R over S is equal to 3 over 10. Okay, so if we multiply those two fractions together, we're actually going to get Q over S, right? The R will cancel on the top and the bottom. So Q over S is equal to 5 over 2 multiplied by 3 over 10. I'm going to cancel the 5 and the 10, so that just gives me a 2 on the bottom. And this creates a fraction of 3 over 4. So the ratio is 3 to 4, and that option is C. Okay, moving on. Okay, we've got uranium-235 undergoing fission to produce 2 smaller nuclei. Which of the following diagrams, if any, could represent this process? Okay, so what they're likely going to expect us to do is sum the mass number and the neutron number. Both of those numbers should be conserved. So with these diagrams that have a neutron on both sides, I'm going to cancel a neutron on both sides. You can do that because you know that you're conserving the neutron number. So what I would do in diagram 2 is I'm going to first sum the mass number. So 137 plus 96 plus 1 plus 1, that should equal 235. And yes, that does. Does 38 plus 54 add to 92? Yes, that will as well. So diagram 2 is correct. Diagram 3, let's add the mass number together again. This one's not going to work. You don't actually have to add up the numbers fully. You can just add up the final digit. So if we add 7 from the 87 to 5 from the 145 plus 1 plus 1, you know you're going to get a number that ends in 4 because that adds to 14. So we want a number that ends in 5, so this one definitely can't work. Okay, let's just check diagram 1 here. So let's do the proton number this time. If I add 56 to 36, I actually get 92, but I didn't want 92 because actually we're adding a proton in on this other side here, so that adds 1 to my proton number, so I should be getting 93. So actually this does not conserve proton number, so we can rule out diagram 1. So the answer is only 2. Okay. The mean age of 20 members of a running club is exactly 28. The mean age increases by exactly 2 years when 2 new members join. What is the mean age of the 2 new members? Okay, so to work out the mean age, you sum all the ages together and then you divide by the number of runners there are. So I'm going to call that sum of ages, the original sum, S, and there are 20 members of this running club. So S divided by 20 equals 28. And I can work out the sum of the ages in the running club before these 2 new members join. That's going to be 560. Okay, now I add another 2 people to my running club, so I'm going to add that sum plus an X and a Y. These are my 2 new runners. And now I would divide by 30. And it says that the mean age increases by exactly 2 years. Sorry, I'm not dividing by 30, I'm dividing by 22. And my mean is 30. Okay, so I can multiply by 22 on both sides and get 660. And that is equal to S plus X plus Y, so that's going to equal 560 plus X plus Y. So X plus Y is just 100, and if the sum of the 2 ages is 100 and there are 2 of them, then the mean must be 50, so just 100 divided by 2, so the option is E here. A circuit consists of a 5 ohm resistor and a variable resistor connected in series with a 24 volt battery. The variable resistor has a minimum resistance of 3 ohms and a maximum resistance of 15 ohms. The battery and the connecting wires have negligible resistance. What is the maximum power dissipated in the 5 ohm resistor? So I'm just going to draw a quick diagram for this here. So it looks something like this. Oops, sorry about that. Okay, so I'm going to make this my variable resistor. That's the symbol for a variable resistor. And I'm going to call the resistance RV because it varies. This is the 5 ohm resistor, and we have a 24 volt supply. Okay, so what is the maximum power dissipated by the 5 ohm resistor? That depends on the resistance over the resistance of the variable resistor. So I'm going to first use a potential divider equation to work out this voltage here, the voltage over my 5 ohm resistance. So the voltage over my 5 ohm resistance would be equal to my 24 volts in multiplied by 5. 5 ohms is the resistor in question, over the total resistance. So the total resistance is 5 plus RV. So you can see from this equation that my highest voltage over my 5 ohm resistor is when my variable resistor has its lowest resistance. So that lowest resistance is actually 3 ohms. And we're going to want the voltage to be as high as possible over the 5 ohm resistor because we can use this equation to work out the power dissipated. So the power dissipated over our 5 ohm resistor is V squared, where we're talking about the voltage over our 5 ohm resistor, divided by the resistance of our 5 ohm resistor. Okay, that can be derived quite easily using Ohm's law and P equals current times voltage, or P equals IV. Okay, so let's work out this voltage. This is going to be 24 times 5 over 8. So 24 divided by 8 is equal to 3, so this is just 15 volts. Okay, then we're going to get 15 volts squared over 5 ohms. So 15 over 5 is just 3, so we're going to end up with 3 times 15. Which is just 45 watts. Okay, so the option is D. Okay. A medical scanner is bought for £15,000. The value of the scanner depreciates by 20% every year. By how much has the scanner reduced in value after 2 years? Okay, so a lot of people start this question by saying, oh, I can write an equation for the value as time goes on. And it would be something like this, but really this is overcomplicating the problem at this stage. You don't need to do this, but I'll just show you what it would be here. So if this is my time at the top here, you can just plumb in there to find your value after so many years. But it's only 2 years, and 20% is pretty easy to calculate, so I would just work out what 20% of 15,000 is. So 10% is 1,500. So 20% is 3,000. So it loses £3,000 in the first year. After it's lost those £15,000, it's worth £12,000. Okay, and 20% of £12,000 is £2,400. Okay, so we just need to add those together, and that's the total reduction in value. So that's answer C. Okay, the total power radiated by a star is given by this equation, where r is the radius of the star, T is its surface temperature, and K is a constant. The power currently radiated by the sun is 4 times 10 to the 26 watts. Towards the end of the sun's life, its radius will increase by a factor of 100 and its surface temperature will decrease by a factor of 2. What will be the power radiated by the sun when these changes have occurred? So all we need here is that the power is proportional to the radius squared and the temperature in Kelvin to the power of 4. Okay, so if its surface temperature is halved, then that will actually be equivalent to a reduction in 1 over 2 to the power of 4. Okay, and the increase in radius by factor 100 will be equivalent to an increase in power by 100 squared. So we can just multiply our old power by this this constant, or this change, 4 times 10 to the 26. Okay, so 1 over 2 to the 4, that's actually going to be 1 over 16. Okay, 1 over 16. And times 100 squared, I'm going to call that times 10 to the power of 4. So if I do this, I know that I've got a 4 times 1 over 16, which is going to give me 1/4, which is 0.25. So I should end up with 0.25 times 10 to the 30. I'm just adding the power of 26 to the power of 4. And if I want to put that in standard form, I would take one of those powers of 10 and change it to 2.5 times 10 to the 29, which is option D. Okay. A point A is 4 kilometers east of a point B. The bearing of C from A is 330 degrees, and the bearing of C from B is 60 degrees. Find the distance BC. Okay, so this requires a diagram. You've got to be quite careful with these. A point A is 4 kilometers due east of a point B. So I'm going to put B here, and I'm going to put A here. I'm going to make this, I know that distance is 4. Okay, so that's 4 in the middle. Should have left myself a little bit more room. Okay. The bearing of C from A is 330 degrees. So if I make this direction north, okay, so that's my north, then I know that C is going to be on a bearing of 330 degrees. So if I go anti-clockwise, it's just going to be 30 degrees here. Okay, so that's 30 degrees there. I'm just going to draw a line here. And from C, the bearing is from B, the bearing is 60 degrees. So doing the same thing, but this time I am going to use the 60 degrees from the bearing. I know that this angle here is 60. Okay, this is quite interesting. So this means that if I draw a third line along the bottom here, this angle on the inside here, this angle on the inside, oh my god, this angle on the inside is 30 degrees, and this angle on the inside is going to be 60 degrees. So something that I can work out in this triangle is this third angle up here. I know it doesn't look like it because I've not done this problem. It's going to be 90 degrees. So we actually have a right-angled triangle, which is much easier to work with. So I'm going to redraw it as a right-angled triangle. I'll make it look something like a right-angled triangle. And I know I've got 60 degrees here, 30 degrees there. So I'm actually looking for this distance BC, which is the one next to my 60 degrees here. So I'm actually going to be using sine 60. So if you use sine theta equals opposite over hypotenuse, it's going to be 4 sine 60. You're expected to know sine 60, sine 30, sine 45, and cos and tan, all of them, you need to know them. So sine 60, I know that that is root 3 over 2. So 4 times root 3 over 2 is going to be 2 root 3. And that is option B. Okay. A transverse wave is traveling through a medium and it has a frequency of 5 Hertz, a wavelength of 4 centimeters, and an amplitude of 3 centimeters. What is the total distance traveled by a particle of the medium in 1 minute? Okay, so this is not what most people are expecting. Most people see these numbers, they see frequency, they see wavelength, and their mind immediately jumps to V equals F lambda. Okay, you don't actually need to do that here. It's not asking anything about the velocity of the wave itself. It's asking about the total distance traveled by a particle of the wave. So think of this as I drop a stone into a pond and I create ripples on the surface. Okay, those ripples pass along like this. Okay, and they keep moving that direction. Okay, with this wave velocity. But an individual molecule of water, say, actually all that will ever do is oscillate up and down as the waves pass. Okay, it won't move left to right. It is just oscillating up and down. That is the interesting thing about waves. They transfer energy without transferring mass, without transferring any mass. So you can think about it as like a laser. You point a laser at someone, you could burn them, or you could throw a rock at them, but one of them is a wave, the other one is not. When you're throwing the rock, you're transferring mass. When you're pointing a laser at them, you're not transferring any mass. Okay, so let's work out this total distance traveled. So as one wave passes, your object, your particle of water, is going to go up to the amplitude, back down again to the equilibrium position, then back down to a displacement of negative the amplitude. So you can think of that as, so far it's moved 3 amplitudes, and then it moves back up again to the equilibrium position. So it actually moves a total distance of 4 times the amplitude, and that's just in one wave. 4 times the amplitude in just one wave. So that'd be 4 times 3 centimeters, which is 12 centimeters. But this wave has a frequency of 5 hertz. So 5 hertz means that in every second, 5 full cycles of the wave pass a certain point. Okay, so 5 of these up, down, down again, and then back up again to the equilibrium position. 5 of them pass every second. But we've got 1 minute. So every second, 5 of these waves pass, and we have a total of 60 seconds. So we're looking to sum this. So 12 times 5 is 60, so it's 60 squared, which you should realize is 3,600 centimeters. Okay. So moving on, the quantities x and y are positive. X is inversely proportional to the square root of y. So I could write that as x is equal to some constant k over the square root of y. Okay. When x is 8, y is 9, what is the value of y when x is 6? Okay, so we need to work out this constant k. I'm going to put an 8 is equal to k over root 9, which is just 3. So k is 24. Okay, so now I can put in this new value of x, and I can say that root y is equal to, just rearranging this equation, 24 over x, which is 6. So 24 over 6 is just 4. And I know they're positive, so squaring this square root, I'm going to just square the other side as well. So 4 squared is 16. The answer is F. Okay, moving on. Right, we have a motor. It's used to lift a mass of 5 kilograms using a pulley system as shown in the diagram. The pulley is secured to the roof using a coupling. Okay, the motor needs to cause the mass to accelerate upwards at 0.8 meters per second. So this is our acceleration. Okay, that's 0.8. Okay, what is the minimum tension force that the coupling must be able to withstand without breaking? Okay, interesting question. So, seeing as they've given us the acceleration of this 5 kilogram mass, I know I'm going to have to consider the forces on that 5 kilogram mass. So, if it's being pulled upwards, there's got to be a tension in this rope. And that tension will be the same as the pulling force on this side from the motor. So those two tensions are the same. And that's just a consequence of Newton's third law. Okay, so we also, though, have a mass, here, so this means it has a weight. And because G is 10, that weight is going to be 50 newtons, just using mg for weight. So if I do F equals ma on this 5 kilogram mass, I can say I'm using the upwards direction as positive, tension minus 50 newtons, that's my F, has got to be equal to a mass of 5 kilograms times 0.8, so 5 times 0.8, which is equal to 4. Okay, so my tension is 54 newtons. Okay, just adding the 50 to the other side. But that's not really what they asked for. They asked for the tension in the coupling. What's the maximum, sorry, what's the minimum tension that the coupling must be able to withstand? So if we think about the pulley, then the forces on the pulley are a tension T downwards on the left, but also tension T downwards on the right. So there's in fact 2T pulling the coupling down. So there's actually got to be a tension of 2T here, keeping that pulley from accelerating downwards. So that is the maximum force, 2T, and 2T is 108 newtons. Okay. Okay, a trapezium, and it's given us the area, it's given us the side lengths all in terms of x. We can use the equation for the area of the trapezium, or if you don't know that, you can just use a square, or sorry, a rectangle plus a triangle to work this out. That will also work. You do have to make the extra step of working out the base of this triangle. So I'm just going to use the formula. Area is equal to A, which is my sort of top length here, plus B, which is my other parallel side along the bottom, divided by 2 times the height. Okay, so A plus B divided by 2, that's going to sum to 2x minus 4. 2x minus 4 divided by 2 is just x minus 2. And then my height is just x. So I've got x minus 2 times x, and that is equal to 120 centimeters squared. I'm asked to work out the length of RS, so I'm asked to work out x plus 5, but to do that I need to work out x. So if I expand these brackets, I'm going to get x squared minus 2x minus 120 equals 0. So I'm looking for a number, well, two numbers that multiply to give minus 120 and add to give minus 2. And I can work those out pretty easily. So it's going to be x minus 12 in brackets times x plus 10. Okay, so 10 minus 12 is minus 2, and minus 12 times 10 is minus 120. So that gives me two solutions. X is either 12 or x is minus 10. You can't have a height of a trapezium that's negative, so the actual height is 12, and RS is 12 plus 5, which is our 17. So a lot of people will write down 12 here at this point. They think they've solved the quadratic, therefore they've got the solution. Be careful, read the question, it says RS. Okay, moving on. Right, we've got a heater connected in series with a resistor and a 6-volt battery shown in the circuit. Good, I don't have to draw it. The total resistance of the circuit is 15 ohms. In 3 minutes, 180 joules of electrical energy is transferred into other forms in the heater specifically. How much charge flows through the heater in 3 minutes, and what is the voltage across the heater? So I always try to answer these two-parter kind of questions. The first part first. I think usually they write it the way round that is easier. So I'm going to first try and answer what the charge is flowing through the heater. So I can do that just by using V equals IR. If I work out the current, then I can use current is equal to charge over time to work out the charge. So the total resistance is 15 ohms. The voltage is 6 volts. So if I rewrite this as current is equal to 6 volts over 15 ohms, I can sort of cut that down. I'll divide by 3 on the top of the bottom. I get 3 over 5, or 0.6. Okay, so 0.6 amps. If we use IT, current times time equals charge, then we can work out this charge in coulombs. So it's 3 minutes, so that's 3 times 60, which is 180. So I'm going to use 180 times 0.6. So this is like saying 60%. 10% is 18. 6 times 18, what's that? 108? I think it's 108. 108, is that an option? Oh, must have made a mistake somewhere. Let's have a look. Divide this by 3. Ah, it's 2/5. So it's not 108. This should be 0.4. So this will happen. You need to work backwards. It's 0.4 instead. So 4 times 18 is 72. Okay, so that's better. I know it's one of these two options here. Okay, so now I need to work out the voltage over the heater. Okay, what's the voltage across the heater? So I actually know the amount of electrical energy that's transferred into other forms, so I can use this equation. E equals the voltage across the heater times the charge flowing through the heater will be the energy dissipated by the heater. Okay, so you can think of this as, if you haven't met this equation before, use power equals current times voltage. If you multiply both sides by time and assume that the voltage is constant, you can say that this is just energy over time, and current is just charge over time. If you then cancel out the over times, you have that equation that I just quoted. Okay, so we know the energy is 180, we know the charge is 72, so we just need to do energy divided by charge. That will give us our voltage. So 180 divided by 72, well, that's actually something we just kind of worked out in reverse, right? We just did 180 times 0.4 is 72, so the answer is just 0.4 here. So it's going to be 0.4 volts and 72, which is option E. Okay. So make B the subject of the formula. Okay, not too bad. So I'm going to multiply by the 3b squared minus 1, and that will give me 3ab squared minus a is equal to b squared plus 2. Okay, so taking the b squared away and adding the a to the other side, I'm just kind of collecting like terms. I end up with 3ab squared minus b squared is equal to 2 plus a. If I factor out the b squared and then divide, if I factored out the b squared, I'd get 3a minus 1. If I divide by that 3a minus 1, I'm going to get 2 plus a over 3a minus 1. And then all I need to do is square root, taking a plus and a minus. So the answer is B. Okay. Next question. Okay, a cubic block, and it has a hole through it. We're given the weight of the block, and we're asked to work out the density of the material. So if we have the weight and we assume G is 10 newtons, we can divide by that 10 newtons to work out the mass, which is 3, right? 30 newtons divided by 10 is just 3, but 3 kilograms, and the answer is in grams, so I'm just going to call that 3,000 grams is my mass. Okay, but to work out the density, I need to do mass over volume. Mass over volume is density. So the volume of my box, if it didn't have the hole in it, it's a cubic box, so it's 10 by 10 by 10. So that would be 1,000 centimeters cubed. centimeters cubed, but then I need to take away the volume of this hole, which is a square hole, so it's 5 by 5 by 10, which is 250 centimeters cubed. Okay, so 5 times 5 is 25 times 10, 250 centimeters cubed. So I end up with a volume of 750 centimeters cubed. If I do mass over volume, 750, so 3,000 divided by 750, then this is going to divide quite nicely. 4 times 750 is 3,000, so I know the answer is 4 grams per centimeter cubed. So the answer is F. Okay, moving on. Right, another kind of volume question. We have this metal sheet, okay, that's given here, PQRS, and it's kind of curled up into a cylinder, right? And we're asked to work out the volume of the cylinder. So if we're going to work out the volume of the cylinder, we have the length of the cylinder or the height of the cylinder. We just need to know this radius and we can work it out. Now, the way that this is curled around, that PQ has just curled around to become the circumference. So P is here now and Q is right next to it. So very easy to work out. The circumference is just 5 meters. So 5 is going to be equal to 2 pi r. So 2 pi r. So we can say that the radius is 5 over 2 pi. 5 over 2 pi. So if I work out the area of the cross section, that's going to be pi r squared. So pi r squared. Then I would just times that by my height, which I know is 10, to work out the volume. So pi r squared is now pi times 25 over 4 pi squared, which I can write as 25 over, so it'd be 4 pi squared, but if I cancel out a pi on the top and a pi on the bottom, it's just going to be 4 pi on the bottom. So 25 over 4 pi. If I just put a 0 on the end to times by 10, I can see that answer isn't there, but I haven't really cancelled it down. If I divide top and bottom by 2, then the answer is C. Okay, so half of 250 is 125, half of 2 is 4. Sorry, half of 4 is 2. Okay. All right, wordy question now. The diagram shows 4 solid steel balls, P, Q, R, and S, which are of identical size. Some of them are shiny, some of them are dull. Okay, it's clear from the diagram. Some of them are in a warmer room than the other one. Okay, and their temperatures are different. Okay, so which 2 balls lose thermal energy by convection, and which ball emits thermal radiation at the greatest rate? So let's start with the first part of the question. Which 2 balls lose thermal energy by convection? That has to be P and Q, because they're in a room that is cooler than them. Okay, so you can think about it as the air right next to P and Q will get heated up, and then it will lower its density, and it will rise on a convection current in the room. Whereas R and S, they're at the same temperature as the air particles in their room, so they will not heat up the air at all and won't cause any of these convection currents. So we're looking for only the ones that give P and Q as the loss of thermal energy by convection. So it's just these ones here. Then the greatest rate of emission of thermal radiation. So dull surfaces emit better than shiny surfaces. In fact, in physics we use a black body radiation. That's an idealized object, a perfect emitter. It's called a black body. So it's going to be the one of the black balls, so either Q or S, but it's actually going to be the ball S because it has a higher temperature. So it didn't say which one emits net thermal radiation. Okay, it just says emits thermal radiation at the greatest rate. So the hotter the object, the more it will emit, but also because it's in a hot room, the more it will absorb. But it isn't asking about that. So you can just think about it as you can draw the curve of radiation emitted, and the hotter the object, the greater the area under this curve. So usually it looks, this is the sort of black body radiation curve. This would be wavelength, and this would be sort of the intensity of thermal radiation emitted at this temperature, and it always sort of curves up to a point and then flattens out sort of slowly like this. Okay, so the higher the temperature, the higher this curve is going to be, and also the higher the lower the wavelength it's peaked at. So the answer is going to be S here. So the answer is D. Okay. So which one of the following is a simplification of this expression? Okay, so you would assume that you have to multiply by the x squared minus 2 on the bottom, make it into one fraction. A lot of people will do that. That will solve your question. I just don't think it's the fastest route. So it will result in you trying to solve a quadratic equation on the top. But instead, let's see if we can solve it a bit quicker. Let's write it as 4 plus, let's make it into an x squared minus 2 on the bottom. I would write it as okay, so what am I doing here? Perhaps the best way is to multiply top and bottom with the 4. No, I think there is a good way of doing this, a quicker way of doing this. If you can't see it, then don't mind. Ah, it's a difference of 2 squares on the top, so I can make that a 2 minus x, okay, and 2 plus x. It took me quite a while to spot that difference of 2 squares, but it is there. So on the bottom, you can factorize this as well and make it x minus 2, and 2 minus x and x minus 2, they are just the same, right? They are, one of them is the negative of the other. So if I cancel this out with this, I just have to change this plus sign to a negative sign, and then I have 4 minus 2 plus x over x. Okay, this is all in brackets here, I suppose. Sorry, that should be a bracket. Okay, so this is going to end up being 3 minus 2 over x. So that is option A. Okay, moving on. The diagram shows the velocity time graph for an object traveling in a straight line over a period of 30 seconds. Okay, so as I mentioned earlier, the gradient here is the acceleration, and the area under the curve, you can just think of that as actually the displacement. So this area under here is a positive displacement. While the velocity is positive, you're moving away from your start position, so you have a positive displacement. And then this area under this curve here would be considered moving back towards your starting position, so a kind of negative displacement. So the total distance traveled, which is the first thing they asked us to work out, we can just think of that as the displacement forward and the displacement backwards, but added together as though those numbers aren't vectors, they're just scalars. Okay, so those, you know, when you're talking about distance, you're talking about a scalar number. Okay, so if we do that, it's going to be 8 times 20 divided by 2, so that will be an area of 80 under there, 80 meters. And this one will be 10 is the base times 2, which is sort of the height, and then divided by 2, so it's just going to be 10. So the total distance is going to be 90, which are these options here. The distance from the starting position, though, it's going to be 70 because you move 80 forward and then 10 back, because this area of 10 meters is below the axis. It's like a negative 10 meters. So you're moving back towards your start position. Your average speed, well, see, it says speed here, not velocity. So if it said velocity, you would be using your displacement over time. But if you're using speed, average speed, you want to use your distance over time. So we know it took place over 30 seconds. So we've got a distance of 90 meters, just doing distance over time, over 30 seconds. that's going to be 3 meters per second. So it's option A. Okay, not too bad. During summer activities week, 120 students each chose one activity from swimming, archery, and tennis. 46 of the students were girls, 36 of the students chose tennis, 2/3 of these were boys, 25 girls chose swimming, 27 students chose archery. Okay, so these questions tend to overload you with information, but the easiest thing, I think, is to draw it's kind of like a probability tree, but I'm not going to write probabilities here. I'm just going to write like the number of people in each group. So the question first splits it into boys and girls, so that's quite easy to do. So let's split it into boys and girls. There are 46 girls, and because there are a total of 120, that means that there are 74 boys. Okay, so if we look at this question, it says a boy is picked at random. So we're more interested in the boys' side of things than the girls' side of things, but I think we're going to need to know something about both of them to actually answer this question. So I'm splitting the girls up into tennis and what else was it? Swimming and archery. Okay, so TSA, and I'll do the same for the boys. So 36 students chose tennis and 2/3 of these were boys. So 1/3 were girls, so that's 12 there for tennis, and for the boys for tennis it's 24. Okay. 25 girls chose swimming. Okay, fine. 25 there. And 27 students chose archery. But actually we've got 2 of the 3 options for girls' sports. So we can work out how many girls chose archery. So 25 plus 12 is 37. 46, take away that 37 should give us our archery, which is just 9 girls chose archery. But there were 27 students choosing archery in total, so the other 18 were boys. Okay, and then we're just looking for the boys who are swimmers. Well, that's going to be 74 minus 24, that's 50, minus 18, that is 32. So 32 boys were swimming, so we have 32 over 74. That is an option there, but you can cancel that down to, if you halve the top and the bottom, it's 16 over 37, because the option is D. Right, bronze is a mixture of tin and copper. A particular sample of bronze contains 10% tin by volume. In other words, 10% of the total volume of the sample is tin and 90% of it is copper. Okay, what percentage of the mass of the sample is tin? Right, and we're supposed to give our answer in terms of x and y. So we know that density is equal to mass over volume. Okay, so I'm just going to look at this material as having all the tin at one end and all of the copper at the other end. That's just the way I'm gonna look at it. So let's call this the tin end because only 10% is tin, and this the sort of copper end. And I'm just going to use x and y from now on. I don't want to talk about it in terms of Cu and Sn. That's going to be annoying. I'm not going to use periodic symbols. So 10% of the volume is tin. So this is 10% here. Okay. Oh, 10%. Well, you know what percent symbol looks like. This is 90% here. Okay, there you are. So we can work this out. I'm going to just write this in terms of the mass of y and the mass of x. So I'm going to say that the density y is equal to the mass of tin over 10% of the volume, so 0.1 of the volume, the total volume here. Okay, so the volume of this lump. With x, I can do a similar thing. X is equal to the mass of copper, mx, over 90% of the volume, 0.9 times V. So what I'm actually trying to work out is the percentage by mass of the sample is tin. So the percentage by mass, the way I would work that out is they've all got times 100 on the end, so I can work out the fraction by mass, and then the times by 100 is just turning that into a percentage. So the fraction of the mass, you could just work that out as my, that's the mass of tin, over my total mass, which is just mass of tin plus mass of copper. Okay, so I can rearrange these equations and put in my densities. So if I rewrite this, I'm going to get 0.1 times v times y on the top. So actually, you can see here that all of these are going to have a times v in them. So you're going to have a 0.1 times v times y for my, and a 0.9 times v times x for mx. So I'm not going to bother writing down v. I'm just going to know that that's going to cancel later on. So I can just write 0.1y over 0.1y plus 0.9x. Okay, now I don't want to leave it in this form because that's not the form given there. So if I times everything by 10, this would be y over y plus 9x, and that is option E. Okay, so the times 100 is just there to turn it into a percentage, not a fraction. Okay, next question. Which of the following expressions is equivalent to this? Oh, okay, so 9 is 3 squared, 27 is 3 cubed. So I'm not going to bother writing this out with all of the 3's everywhere. I'm just going to think about the powers. Okay, so 9 is 3 squared, so 3 to the 2, and then that would be multiplied by 2n plus 1. So I can just write this in terms of the powers. That's 2 times 2n plus 1. So that's just going to be 4n plus 2. Okay, so ignore that curly 4 there. I'm just expanding this. So my 3 is just, you're just going to add on this power of 3, because when you multiply 3 to the power of x plus 3, times 3 to the power of y, you just get 3 to the power of xy. That's kind of the rule here that we're using. So we would be adding on 4 minus 3n, and then it's divided by 27 to the power of 2 minus n. So that's really going to be taking away the power, but 27 is 3 to the 3. So it's take away 3 times that power on the bottom. And it's take away because it's divided. Okay, so if I cancel some of this stuff out, actually I'm going to expand this bracket first. I'm going to get a minus 6 and a plus 3n. Okay, so I've got 4n minus 3n here, and there's a plus 3n, so I can cancel those out. And then I've got a minus 6, and I've got a plus 2 and a plus 4. So the answer is just going to be the 4n. It's just going to be 4n. So the answer, of course, is in terms of 3 to the 4n, but you don't. If you write it all out, that's going to waste too much time. Okay, so when a stationary uranium-238 nucleus decays by alpha emission, it forms a nucleus of thorium-234. The total kinetic energy produced in the decay is E. What is the kinetic energy of the alpha particle? Okay, interesting. So this is kind of a collision. It's more of an explosion, but you can think of it as a conservation of momentum problem. So the alpha particle has a mass of 4, and let's use units of atomic mass units. Okay, so we can just say that this is 4 mass and this is 234. That's the mass of this one. Okay, so we know because we started with no momentum here, nothing is moving, no momentum on the before side, we must have no total momentum on the other side, on the after side. So we can say that for, I'm going to call that V1, this is V1 here, is going to be equal to 2, 3, 4, V2. Okay, and that's my velocity of my thorium. Okay, so we know that the kinetic energy after the collision is equal to E, so we can say that that is 1/2 times 4 times 1 half times 4 times v1 squared. So I'm just going to write that as 1 half times 4 is 2, so it's going to be 2v1 squared. And this other one is going to be 1 half times 234 times v2 squared. So half of 234 is 117. So plus 117 v2 squared. Okay, so it's up to you if you want to write that as a fraction or not. I think maybe it might have been sort of smarter to ignore the half. I think you could probably ignore the half here because everything is in terms of a fraction, so it would probably be fair to do that. So if I'm looking for the percentage of this total energy, or the fraction of this total energy that's given to the alpha particle, I could just say it's going to be 2v1 squared, that's my energy of my alpha particle, over the total energy, 2v1 squared plus 117. But if I put a v2 squared in here, I'm not going to be able to work out this fraction in terms of just a number. I need to use this equation to turn this v2 into a v1, right? So what I'm going to do is I'm going to rewrite this equation as v2 is equal to 4v1 over 234. 234. Okay, so I could probably I'm going to cancel this down to 2 over 117. Okay, so I'm going to end up here with, this should have been a v2 squared, and v2 is now 2v1 over 117. So it's going to be 2v1 over 117 squared. Okay, so now you can see that I actually have a v1 squared on the top and on each term in the bottom. So I end up with 2 over 2 plus 117 times 4 over 117 squared. Oops. 117 squared. So one of my 117s on the top and my 117 on the bottom of that little fraction down there, they can cancel. So if I times by 117 now on the top and bottom, I'm going to end up with 2 times 117, which is going to be my 234, over 234 plus 4. So it's 234 over 238. That should be my answer. 234 over 238. That is option D. And actually, maybe you didn't have to do all of this calculation. If you want to be sure of the answer, you've got to do the calculation, right? But if you're very clever, you could rule out quite a few of these. So it can't be all of the energy, otherwise you haven't conserved momentum. It's not going to be exactly half the energy, because that would be a very symmetrical situation. That would be like if the uranium-238 split entirely in half. And if you think about it, in this half mv squared equation, the velocity is squared. So the velocity matters a great deal more in kinetic energy than the mass does usually. So it's going to be quite a high proportion of this energy that is given to the alpha particle. Alpha has a lot of energy, so you could probably rule out A and B on those front and just go straight to D, but you're taking some risks there, so working it out is always the best solution. Okay, so next question. Got PQRS, it's a regular polygon, it has n sides, and the side PQ is here. Okay, so we need to represent n, the number of sides, in terms of x. That's what the question is saying. And QRT is that x there. So what I can use, the sort of formula I always use for this, is the external angle of an n-sided regular polygon is 360 degrees, okay, over n. Okay, you can think about that as if you sort of walk in the direction of the sides of the polygon as you're going around. So let's just take a normal, I don't know, like a square. Okay, so let's say originally you were walking in that direction, you would then turn through 90 degrees to start walking in this direction, and then here you would turn through another 90 degrees, sorry, another 90 degrees to start walking in this direction, and again, and in the end you have turned through 4 lots of 90 degrees, and you'd be pointing in the same direction. So you're always going to turn through, you're always going to have a number of turns that's equal to your number of sides, and you're always going to end up pointing in the same direction. So you're always going to turn through 360 degrees, and you're going to do it in like n smaller turns. So that's why this exterior angle formula always works. Now all we need to do now is just look at where the exterior angle is on our diagram. It's actually this bit here. That's our exterior angle. So if we look at this triangle, it's an isosceles triangle with 2 exterior angles as the smaller angles. So that's an exterior angle. That's an exterior angle. So we can say that x is equal to 180 minus 2e, or minus 720 over n. Okay, so minus 2e is minus 720 over n. So we've got to rearrange this formula to give it in terms of n. So let's do that. So if I sort of swap this around, I can make this 720 over n is equal to 180 minus x. So what I'm doing there is I'm just adding 270 over n and taking away x. Okay, so then I can flip this equation and multiply by 720. So if I divide both sides, so if I do 1 divided by both sides, I'm going to flip both sides of the equation. That will give me n over 720 is equal to 1 over 180 minus x. So that will be 720 over 180 minus x. So is that an option there? Yes, it's E. Okay, great. A student carries out an experiment to measure the speed of sound. A loudspeaker that emits sound in all directions is placed between 2 buildings that are 128 meters apart. Okay, as shown in the diagram. The loudspeaker is connected to a signal generator that causes it to emit regular clicks. The student notices that each click results in 2 echoes, one from each building. The rate at which the clicks are produced is gradually increased from 0 until the echoes coincide with a new click. Okay, this is interesting. So we're going to need to talk about the distance that these sound waves travel when they echo off the buildings. So the closer building, the time it's going to take is going to be important here. So we know it's going to go 48 meters there, bounce off the building and do 48 meters back. So 2 times 48 is 96. So we've got the speed of sound in air. We can use that to work out the time. So time equals distance over speed. So the distance is 96. The speed is 320. Oh, and 96 is 3 times 32. So I can cancel this down to, so this is 3 times 32 on the top, and I've got 320 on the bottom. So if I divide by 32 on the top and bottom, I get 3 over 10, or 0.3. Okay, so it's going to take 0.3 seconds for that sound to bounce back off the closer building. The further building is actually, that's 80 meters, so it's going to be the same equation, but the distance, let's call that T1, and T2, the distance is now going to be 160, so 80 times 2. 320 on the bottom here, so that's just 0.5 seconds. Okay, interesting. So if they both coincide with clicks of the signal generator, then it must mean, and that signal generator has started at I think a low frequency. It's increased from 0, so the rate at which the clicks are produced is gradually increased. So it starts at a very or sort of slow place, like a click, then wait a long time, then another click, and then it sort of speeds up to a click, 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 click. Okay, so we know that if both of those echoes are coming back every 0.3 seconds, then they're actually coming back. So if you think about it, at 0 they would come back, at 0.3 seconds they come back, at 0.5, and then at 0.6, and then at 0.9, and then at 1 second they'd come back as well. So if you think about it, they're coming back always on multiples of 0.1. They're always coming back on multiples of 0.1. So if you were producing a click every 0.1 seconds, if that was your frequency, then you would have an echo coinciding with clicks. So if it happens every 0.1 seconds, that's like our time period between clicks. 1 over time period gives our frequency, and 1 over 0.1 is 10 hertz. So that's the answer there. Okay, advanced now. So let's see if there's much difference. So when x equals 2 is substituted into this expression, the result is 0. When x equals 1 is substituted into the same expression, the result is minus 3.5. Find all possible values of p. Okay, so this is just simultaneous equations kind of dressed up nicely. So I'm going to substitute in 2 sort of straight away. So 8 is 2 cubed plus 4p plus 2q plus p squared. That's equal to 0. Okay, oops, got to get a 0 in there. That's nice. Okay, let's do it with 1 as well. So we're going to get 1 plus p plus q plus p squared is equal to minus 3.5. Okay, so I'm going to multiply this second equation by 2, and then I'm actually going to add the minus 7 to the other side. So if I multiply it by 2, I'm going to get 2 plus 2 p plus 2q plus 2p squared is equal to minus 7. Okay, is that really what I wanted to do? Yeah, that's fine, that's good. Okay, so then if I add the 7 to the other side, I can make this a 9. Okay, so let's just remember that's a 9. And then I've got a 2q in both equations, so I can eliminate q if I wanted to. So I'm going to do this second equation, take away the first equation. So 9 minus 8 is just going to give me a 1. Okay, so remember this is a 0 on this other side as well when I move the minus 7 over to make 9. Okay, so that's going to give me a 1, and then my p, I have a 2p here, take away a 4p there, so I'm going to get a minus 2p, and I've got a 2p squared, I'm going to take away a p squared over there, I'm going to get just a p squared. Okay, so this is the quadratic that you'd expect to get out. Okay, and actually, I think that's a perfect square, isn't it? That's p minus 1 squared. Okay, so you're looking for two numbers that add to make minus 2 and multiply to give 1. So it's p minus 1 squared, so the answer is just p equals 1. Okay. Right, a parachutist is falling at a terminal speed with his parachute open. Okay, here are the diagrams. Okay, so we've got all of the forces on the parachute. We're treating the parachute like a sort of separate object, and we've got all of the forces on the parachutist. Okay, consider the following equations. Which of these, if any, is the direct result of the application of Newton's third law to this situation? Okay, so many people don't really understand what Newton's third law is about. So if I quote it to you, it would be if an object A exerts a force on an object B exerts a force on object A that is the same in magnitude, the opposite in direction, and it has to be kind of the same type. I always add that one in there just because it helps me think about it. So if one of them's a weight, the other one's going to be a weight. If one of them's a tension, the other one's going to be a tension. If one of them's kind of a contact force, like a normal contact force, the other one is going to be a normal contact force. So we know it's going to be one of these equations with an equals because they're equal in magnitude, right? They're equal in magnitude. So this situation, we have the force from the parachute and the force from the parachutist. They are certainly going to be equal, and that is actually a Newton's third law pair, because it's almost like the parachutist is pulling down on the parachute with a tension, and the tension in the rope in the parachute is pulling up on the parachutist. So they're both tensions. They're in opposite directions. Any sort of tug of war sort of situation where you're pulling on, I don't know, some object here, and you've got another object here, these two tensions are going to be the same. Okay, and that's basically what we've got. Okay, so it's definitely 4. Is it 3 though? So 3 is L equals Q. Now, Q is an air resistance, and L is also an air resistance, but they're pointing in the same direction. So it can't be that one. They're kind of two different Newtons. They're two different forces, really, because whenever you have an air resistance, it's kind of hard to identify the force, that's kind of the Newton's third law equivalent of it. So if you think about it, this person here is being bombarded by air particles, and that creates that sort of air resistance. But those air particles are being bombarded by a human bumping into them. So that's where these Newton's forces are here. It's a force of well, basically an electrostatic repulsion between the electrons in the molecule of air and the electrons in the person when they bounce off each other. So that's where your Newton's forces are there. With the weight of the parachutist is countered by sort of the attraction of the Earth to the parachutist. Okay, so those forces will be of the same size, just worked out by Newton's law of gravitation, but it will cause a massive effect on the person falling out of the air, but it won't cause much effect on the Earth because the Earth has a much greater mass. So that's what I mean by of the same type. If this is a weight, if this is a force of gravity, this has got to be a force of gravity on the planet, attracting it towards the parachutist. Okay, so the answer is only 4 only. There you are, C. Okay, so a square PQRS is drawn above the x-axis with the side PQ on the x-axis. The point P is -5, 0, and the point Q is 1, 0. A circle is drawn inside the square with a diameter equal to the length of the side of the square. Which one of the following? Okay, so this, I think, is the situation we've got here. So this will be our x-axis. Let's make this our y-axis. And we've got one point which is at -5. We've got another point that's at 1. So the length of the side of our square is 6. So we're going to have another point up here which is 1, 6. We're going to have another point over here which is -5, 6. I don't actually think you need this, so maybe don't bother if you're doing this in the exam. You're looking for a circle that has this, the length of the side of the square is the diameter, so the radius of the square is just going to be half of 6, which is 3. So we know we're going to have a 3 squared on this side of our equation. Where's the center of the circle? If it's inside the square, perfectly kind of inside the square, then it's going to be in the center. That is going to be at -2, so a length of 3 from one of these edges, and it's going to be 3 up, so it's going to be at -2, 3. So I can write it as x minus -2, x plus 2 squared. So I'm just using the common equation for working out the equation of a circle. So this is something that you should know from A level. It is that If you want to find the equation of a circle, you need to know the center and the radius, and it's x minus a, where a is the x coordinate at the center of the circle, plus squared, plus y minus b, where b is the y coordinate at the center of the circle, squared, equals the radius squared. So that's why I've got a 3 squared on the other side. So when I work this out, I'm going to get a 9 here, but I'm also going to get a 9 from the y expansion. So the minus 3 squared will give me a 9 on the other side. So I'm going to get a 4 from the expansion of the x squared. There's going to be a 2 squared coming from that bracket. So I know that I can cancel the 9 with the 9 on the other side and just get a 0. So I'm looking for one that has a plus 4. That's the first thing I can sort of work out. So I can eliminate quite a few on that basis, but really I probably need to know the whole thing. So I'm going to have an x squared and a y squared, that's obvious, but I'm also going to have a plus 4x from the expansion of my x squared bracket, and a minus 6y from the expansion of my y squared bracket. So I'm looking for a minus 6y, a plus 4x. They both have an x squared plus a y squared. So the answer is C. Okay, so you don't really need to do the whole expansion. You just need to have a think about how it will expand. Okay, next question. A crate has a total mass of 800 kilograms, including its contents. A helicopter of mass 4,200 kilograms is carrying the crate using a light, inextensible rope as shown. Calculate the tension in the rope. Okay, fine. This crate is accelerating upwards at 2 meters per second. So this is just like the question from earlier with the pulley. We've got a tension on. I'm just going to look at the crate right now. We've got the tension on the rope of the crate, and we've also got the weight of the crate, which is going to be 8,000 newtons. 800 times 10, which is my g, mg equals weight. So I can use the total force, or the resultant force on the crate is T minus 8,000. So that's my F, and that's equal to ma. So m is 800, and a is just 2. It's accelerating upwards at 2 meters per second. So this is 1,600 on this side, and 1,600 plus 8,000 is going to give my tension, which is going to be 9,600. Yes, or 9,600, which is 8,000, 9,600. Yeah, that's correct. Okay, so that's quite easy, that one. The first term of a convergence geometric series is 8. The fifth term is 2. The sixth term is real and positive. What is the sum to infinity of this series? Okay, and they've given us the formula for the sum to infinity. So a is the first term, so a equals 8. The fifth term is 2, so the fifth term, if the first term is a, the fifth term can be written as ar to the 4. Okay, so you're having sort of there'll be 4 jumps each time you multiply by r, right? So we can say that that's equal to 2. And if you want to work out r, you need to divide these two equations. So if this is equation 1 and this is equation 2, we need to do equation 2 divided by equation 1, which will give us r to the 4 on this side, and then 2 over 8 on the other side. 2 over 8 is just 1/4. So it's probably not going to be any of those ones with the fifth power there. If I square root, if I square root this twice, that's the same as taking a fourth root. Okay, so if I square root 1/4, that is a half. So a half times a half is 1/4. I guess I should be doing this plus and minus, but there's a reason why we don't need to bother with plus and minus, and that is that we know the next term in the sequence is actually positive. So if we've got 2 and we're multiplying it by a number to get the next term in the sequence, the r must be positive. So you don't need to worry about plussing or minusing here. Okay, we can just consider it the plus root. So as I said, I take the square root, that's a half. I'll take the square root again, that is 1 over root 2. Another way of writing that is root 2 over 2. Okay, so that's just by multiplying by root 2 on top and bottom. Okay, so we're looking for this sum to infinity. We're going to use that formula, a over 1 minus r. So that's going to be 18 over 1 minus root 2 over 2. Okay, I can multiply everything by 2 here just to get rid of that fraction on the bottom. I'll get 16 over 2 minus root 2. And when I have a surd on the bottom, I want to multiply by a surd on top and bottom, but it's the surd that actually produces a difference of 2 squares. Okay, so this surd on the bottom is going to be 2 plus square root 2, because now we have a difference of 2 squares. That's going to sort of eliminate eliminate the need for a sort of a square root on the bottom, and they always sort of expect you to do that because nobody likes surds on the bottom. Okay, so if I do this, I'm going to end up with, on the bottom it's going to be 2 squared, which is 4, minus square root 2 squared, which is just 2. So we're going to end up with a 2 on the bottom, and on the top we're going to have a 16. So we can cancel them and make it 8 times, so let me just make that clear. So when I multiply these two together, the 2 minus root 2 and the 2 plus root 2, that will give me a 2 on the bottom. I'm kind of immediately cancelling that with my 16 on the top to give me an 8. But remember, I've still got to multiply by this 2 plus square root 2 on the top. So I'm going to end up with 8 times 2 plus square root 2. Let's hope that's an option up there. Yes, it is. It's option C. Okay. Moving on. Right. Oh, this looks like a... Ooh, okay. So this looks like a sort of decomposing this force into 2 force components. That's what I'm going to be doing here, I think. So a shopper pushes a supermarket trolley a distance of 15 meters in a straight line across a level horizontal surface. The shopper applies a constant force of 50 newtons, but at an angle. Okay, fine. The total weight of the trolley and its contents is 350 newtons. Okay. And you need to work out this vertical force. So it's the combination of the vertical forces at the wheels, but we're just going to call it one big vertical force, which is our normal reaction. And we need to work out the work done. So let's do the vertical force first. I'm going to split this into 2 components. So one of them pushes it to the right, and one of them pushes the supermarket trolley sort of into the ground. Okay, and I know that if I sort of, let me draw this triangle out here. Okay, sorry, that's a bad triangle, but don't worry about it. That's going to be my 37-degree angle. Okay. That's going to be my 37-degree angle. My hypotenuse is 50. Almost always when you're splitting forces into their x and y components, your hypotenuse is going to be the total force. And so my sort of force that goes downwards, oops, let's do that. The force that pushes downwards is going to be 50 sine 37. Okay, so if there's one thing that I think is important is not having to write opposite, adjacent, and hypotenuse every single time, because that'll really slow you down. So learn to look at this 37, go, the opposite side is this one, that's the one that pushes down, and opposite, if I have the hypotenuse, means that I can do opposite equals hypotenuse times sine. So hypotenuse is 50. 50 times sine 37, luckily they give us sine 37 here, it's 0.6. So that is just going to be a force of 30 pushing down. But that's not the only force pushing down. We also have the weight of the trolley and its contents, which is 350 newtons. So it's going to be one of these vertical forces is 380. So it's one of these two. Now we need to work out our work done. So if the opposite side was 50 sine 37, the adjacent side is going to be 50 cos 37. In fact, I think this is actually a 3, 4, 5 triangle. Right? This is going to be 30 here. That's going to be 30 there, and that's going to be 40 there. So it's just the 3, 4, 5 triangle, but scaled up by a factor of 10. Okay? So look out for them. They will be everywhere in these questions because you have to do these sums in your head mostly or on paper. Okay, so we know our 40 newtons is the force in the direction of travel, in the direction of the sort of displacement. So if you remember one of those first questions with the x and the y axis, and you had to work out what the two quantities represented, they gave a very strict definition of what work done was there. So this is why you've got to use the work done is always equal to the force in the direction of displacement. So we need to use force times displacement to work out the work, and that force is going to be 40. The displacement is equal to 15 meters, so we're doing 40 times 15, which is 600. So it's 600 joules, so that means it's an answer of A. Okay, moving on. Ooh, a nice area problem. Okay, so this kind of looks like a circle theorems problem. Yeah, I think it is. So we know that PC is 20. So I'm just going to draw a line here. That's our 20 centimeters. Okay, and then, I mean, this problem is symmetrical, so we can really consider just one side of it. And I'm going to draw a radius there. If in doubt, draw radii, okay, on your problems. And draw them between sort of points of interest. So where the tangent reaches the circumference, that is a point of interest because I know that from circle theorems, tangents meet radii at 90 degrees. That's a circle theorem. So this is 90 degrees inside my triangle. This is my radius. Oh, I know my radius. My radius is 10. Okay, so if I want to work out... Oh, if I want to work out a lot of things now, I can work them out. So if I want to work out... Let's work out this other side here. So the other side of my triangle, my sort of height of my triangle, if you can consider the base the radius, then the height is the perpendicular side to that. We can work that out using Pythagoras. So that is going to be 10 times root 2 squared minus 1 squared. So I kind of took out a factor of 10, and then I did Pythagoras. So it's going to be 10 root 3. Okay, so that length there is 10 root 3. So if I want to work out the area of this triangle, I know it's going to be 10 root 3 times 10 divided by 2. So it's going to be 10 times 10 is 100. Divide that by 2, that's 50. So it's going to be 50 root 3. And so my two triangles, if I consider the other one as well, that's going to be 100 root 3. Okay. Okay, now I need to think about this sector on the inside here. It would really help if I knew this angle, which I can work out. I can use it's a right angle triangle, so I can use, this is my opposite side, and this is my hypotenuse. So I can use sine of that angle, sine of the angle, which I'm going to call theta. So this is theta. Oops, that's a really bad theta. That is theta. So sine theta is equal to 10 root 3 over 20. That cancels down to root 3 over 2, which is one of the ones you should know. So the angle there is 60 degrees. So actually, the whole angle here is going to be 2 times 60 degrees, which is 120 degrees. And that means it's a third of this whole circle. The whole circle is 360 degrees. We've got 120, so we've got a third. So we can just use pi r squared divided by 3. That is going to be the area of our sector. We're going to take that away from 100 root 3. That's the area of our two triangles. And that should give that shaded region there. So what I've done is I've taken the two triangles, worked out the area of them, I've taken away the sector, and now I can work that out. Both of them are going to have a factor of 100 in them. But looking at the answers, they're going to take out that factor 3 as well. So r squared is actually 100. So this is 100 pi over 3. But look, they're taking the 3 out and maybe the 100. So let's do that. So if we take the 100 out, then we would get root 3 minus pi over 3. But they also took that 3 out. Whoops. They also took that 3 out, so we can write this 100 over 3 and then 3 root 3 minus pi. Okay, left it in a nice closed form there. That is an option. That's option A. Brilliant. Okay, a plank of non-uniform density. Okay, non-uniform density means we don't know where the center of mass is, which has a mass of 15 kilograms, is used to make a seesaw. A pivot is placed under the center of the plank, okay, as shown in the diagram. The buoy of mass 35 kilograms sits at one end, and he is 1.2 meters from the pivot, okay. And there's also a girl of 60 kilograms who sits on the other side. Her center of gravity is here, okay, fine. Where is the center of gravity of the plank, and what is the magnitude of the force between the pivot and the plank? So I'm actually going to I'm going to break my rule here. I'm going to break my rule of doing the first part of the question first and the second part of the question second, because the second part of the question is actually a very easy F equals ma. Okay, so we know the masses of the children. Okay, so that's 350 newtons, so 35 kilograms times 10. Let's just say the pivot, the center of mass is somewhere here. I'm just sort of guessing. It could be anywhere really. I'm not really worried about where it is right now. So that's 150 newtons because it's 15 kilograms times 10, and I think this girl is 60 kilograms, so 60 times 10 is 600, right? So if those are all the forces pointing down, and this is in equilibrium, then there must be a force pushing all of this stuff up, right? And that force comes through the pivot. It's a reaction force at the pivot. So we can work out the size of this force by adding all of these together. 350 plus 150, that's 500, plus 600 is 1100, right? So the only options are this one, this one, this one, and this one. Okay, that rules things out a little bit. So we know, let's work out the girl's moment. So the girl actually has the anti-clockwise moment here. So it would be 0.8 meters times her 600 newtons. So we can say that that's just going to be 80% is 480. Okay, so 480 Newton meters. And the boy, he is 1.2 meters away, and he has a 350. So that would be like adding on another 20%. So that's 35 times 2 is 70. So he has a 420 Newton meter moment that is clockwise. So I was right, the pivot has to be a little bit on the little boy's side. So it's whatever this 150 newtons is times this x. So we kind of cancel some out and say it's on the left, but let's work out x first. So 150 times x plus 420. Okay, so if I take away the 420, I can say 60 is equal to 150. Oops, 150x. So dividing by 150, I can say that is 2 over 5. Yeah, I think that's right. So it'd be 6 over 15, divided by 3 on the top, that's 2, divided by 3 on the bottom, that's 5. So it's going to be 0.4 on the left. Sorry, not on the left, on the right. Okay. 0.4 meters on the right. Okay, is that a possible answer? Yeah, H, last one. Okay, right, we've got a trig equation here. So 7 cos theta minus 3 tan theta sine theta equals 1. So we want to put this in either all cos or all sine. That's the only way we're going to sort of solve this. But the question is giving the answers in cos, so we're going to change this into all cos. So if I write tan as sine theta over cos theta, that That is an identity that everyone should know, really, really important. And it goes along with, so I'll write that down, tan theta equals sine theta over cos theta. True for all theta. That's a sort of definition of tan, if you like. And another one is that sine squared theta plus cos squared theta is equal to 1. I think I'm going to be using both of them here. So let me just scroll down. I'll do it in this gap here. So I'm just going to call cos C, I'm going to call sine S, and I'm going to call tan T, but I'm actually going to replace tan in a minute. So let's call it 7C minus 3, and then I'm going to use S over C for tan. Okay, sorry, S over C is tan. And then it's times sine again, so this is going to be a sine squared on the top, is equal to 1, right? So now I can use the fact that sine squared is equal to 1 minus cos squared, or S squared is equal to 1 minus C squared. So I can write this as 7C minus 3, 1 minus C squared equals 1. So don't worry, I haven't forgotten about the C on the bottom here. I might times everything by C just to sort of get rid of that. So I'm going to times this by C, and I'm going to make this 1 on the side of C. Okay, so now I have 7C squared. I'm going to add another 3C squared from expansion of my bracket there. So I'm going to end up with a 10C squared minus 3 minus C equals 0. Okay, equals 0. Sorry, I'm writing in the gap here. So if I try and solve this, I'm looking for two numbers that multiply to give minus 30. So they multiply to give minus 30. That's my A times my C. And they add to give minus 1. So that's not too bad. Those solutions are, so if they multiply to give minus 30, they add to give minus 1, I can write this as, I'm running out of room here, 10C squared. I'm going to split that minus C into a plus 5C, plus 5C, and a minus 6C minus 3 equals 0. So I'm factorizing it kind of old school. You can use the formula if you want. If you want to use the formula, that's up to you. I'm going to factorize out 5C. So that's 2C plus 1. 2C plus 1. And this is going to be a 2C plus 1 as well here. But the factor at the front is going to be a minus 3. Okay, so I can factorize that into 2C plus 1 in brackets multiplied by 5C minus 3. So 2C plus 1 gives me C is negative a half. 5C minus 3 gives me C is equal to 3 over 5. So my answer is D. Okay, moving on. So I would be a little bit quicker if I wasn't writing this on the board. And potentially, if you want, if you're quick at using the formula, you can use the formula on that one. Okay, so we've got a car of mass 200 kilograms on a fairground ride. It travels at a speed of 5 meters per second from point X. The car is allowed to move down a sloping section of the track without any energy input, so there's no motor or anything. The heights are given. This looks to me to be a conservation of energy problem. How much energy is transferred in overcoming resistive forces as the car travels from X to Y? This is interesting. So these resistive forces, they're just going to happen over a certain distance. But we don't really need to worry about the size of the force. We can just use energy conservation to work out this loss of energy. So at the start, we have two types of energy. we have kinetic, and we have gravitational, right? We have a bit of each. So we know that our change in energy overall is going to equal our loss of energy due to these resistive forces. So let's work out our energy at the start and our energy at the end. So at the start we have 8. This is working out the gravitational potential. So I'm using mgh. So my height is 8, my g is 10, so that's 80, and my mass is 200. So times 200, that would give me 80 times 200 is 16000. So 16,000. Okay, 16,000 joules of height of gravitational potential energy. At the end, I have 2 is my height. So if I could actually do this working out the change, really. You could really do this working out the change. That might be the fastest way to do it, actually. So we could do it working out the change. I've kind of started working out the energies in total. If you're more comfortable doing it that way, it's better not to make a mistake. If you are pushed for time, though, maybe you want to use the change in energies. So GPE1, that is, GPE at the start, I'm calling it GPE1, and then KE1, okay, KE1 is going to be equal to half mv squared. So half of my m is 100, and my v squared is 5 squared, so that's going to be 25 times 100, which is 2,500 joules. Okay, so at the end, the GPE is going to be actually a quarter of what it was at the start. The height is quartered, so I can just use that if I like. So GPE2 is going to be a quarter of 16,000 is just 4,000. Okay, I'm not going to bother writing joules on all of these. The unit is joules. And the kinetic energy, again, is going to be half my mass, which is 100, times my velocity squared, my speed squared, sorry. Doesn't really matter, actually. So that's 9. So 9 squared is 81, times 100. That is going to be 8,100. So that's my KE2. So that's 8,100. Okay, so that will sum together here to be 12,100. And this one here will be 18,500. So what's that going to be in total? 6,400? Yeah, it's option B. Okay. So let's scroll down a little bit more. Right, a complete set of values for A for which this equation has 2 distinct real roots. Okay, so this is basically just using the discriminant. It's not really that bad at all. So the discriminant is b squared minus 4ac. So I'm just going to write it all on one side so I don't make a mistake. So I'm going to write it as minus a plus 2x plus 3 equals 0. Okay, so b squared is a plus 2. Sorry, I'll put that 0 back. Is a plus 2 squared. That's my b squared. Okay, minus 4ac, minus 3 times 3, so minus 4 times 9, which is minus 36. So I'm just going to put 4 times 9 here. Oops, 4 times 9 equals 0. Okay, so I can square out this bracket. It's basically going to become another quadratic in A. So if I do that, I'm going to get a squared plus 4a plus 4 minus 36, so that's going to be minus 32 overall. So if I want to factorize this, I'm looking for 2 numbers that add to make 4 and multiply to make minus 32. So that's going to be a minus, plus 8, a minus 4. What is going on here? A minus 4. Okay, so that's equal to 0. Okay, so A is, right, so we're looking for values where this is actually greater than 0, sorry. I sort of started, I was on autopilot solving equations here, solving quadratic equations. When we're actually looking for two distinct real roots, it's not greater than or equal to 0, it's greater than 0. So that's the rule. If you want to have two solutions to a quadratic, your discriminant has to be greater than 0. So we're looking for when this function, let's call it a function of a, this function of a is greater than 0. So if I draw this function of a, I actually know what it looks like now. It's a quadratic, so it has that classic U shape, but the two roots are -8 and +4. So it looks something like that, right? Where that is going to be 4 there, and this will be -8. Okay, so where it's greater than 0 is where that line is above the kind of A axis, I guess. So this is A, and this is the graph of a function of A. Okay, so I guess that's an f of A axis there. Okay, fine. So where it's above the axis is going to be all of this region here and all of this region here. So it's going to be less than -8 and greater than 4. Less than -8, greater than 4, that's G. Okay. Oh, it's really playing up now. There we are. Got it. Okay, so we've got a diagram here. We're coming to the end. This shows a uniform, solid, heavy cube with sides of D. The cube rests with one of its edges in contact with the table that is perfectly level. The horizontal force P acts on another edge of the cube, and the cube is stationary. Okay, so this is one of those cases where we're going to have to think about both moments and F equals ma. So below are false statements about the forces on the cubes. On the cube, sorry, it is possible that there is no frictional force between the cube and the table. Well, that is definitely not true, because if there was no frictional force, there'd be a net force in this direction, and the cube would accelerate, so it wouldn't be. What does it say? Does it say that it's? It does say that it's perfectly level. The cube is stationary. Sorry, there you are. The cube is stationary, so it's not accelerating. So there's definitely got to be a friction force here that counters P. There must be a frictional force acting to the left between the cube and the table. Well, that's what I just drew. So yeah, that's true. There must be a frictional force acting to the right. No, well, it acts to the left. We just said that. A force P has a clockwise moment about the edge in contact with the table equal to PD. I don't think that's true. So, no, I definitely don't think that's true. So, the rule is that it's the force times the perpendicular distance from the pivot. So, here is the perpendicular distance to the pivot, where that's it. That is at 90 degrees here. Yeah? So, that isn't D. D is shorter than that. So we can kind of rule that out. That's definitely not it's not just PD. So the answer is that it's 2 only. Okay. So, okay, question 41. A straight line with an equation y equals mx plus 3. M is greater than 0, m is not equal to 1, is perpendicular to this line. Okay, well, if we have two, all right, so we're looking for this value of mp, and m is greater than 1, we have two lines that are perpendicular to each other. So straight away, what comes to mind for me is this rule that you may know it as flip it and change the sign. So it means that the gradient of one line times the gradient of the other line is -1. Or you can say, if you want the gradient of m, it is p flipped and then change the sign. So if you flip p, it's 1 over p. If you change the sign, it's going to be 1 over minus p. So 1 over minus p there. Okay, so we need to find the value of m plus p, and to do it, we need to find this length here. So it'd be good to know where these two lines cross the x-axis, and that shouldn't be too hard to work out. It's going to be in terms of in terms of p or m. So I think I'm going to write it. I think I'm actually going to write it the other way around. Sorry, I'm going to write it as p equals minus 1 over m, because I know that m is greater than 1, so I can sort of always think about that in those terms. I'm so sorry about that. I don't know why that's highlighted, but never mind. Okay, so if we want to work out these points, I'm going to call that xl, and I'll call that xm. Let's try and work out where they are. So when let's work out xm first. That one seems the easiest. So that line is crossing the x-axis, so y is 0. So we can say y0, which is our y, is equal to mx plus 3. Is that the plus 3 one? Sorry, I made a mistake there. Let's make that the plus 2. Sorry, xm is really the one that's... Oh, I've made a real balls up of this here. Sorry, that should be the p. So it's minus 1 over mx, and the x is on the top there, sorry, plus 2. So if I rearrange that for my xm, this is the point xm, I'm going to get xm is equal to 2m. Okay, quite simple, 2m. And xl, we're going to do the same thing, apart from this one's a little bit easier. It's actually equal to 0 as mxl plus 3. So xl is going to equal minus 3 over m. Okay, that makes sense because xl is negative. It's in the negative portion of the graph there. So to work out that length, we know the length between them is 5. That's just going to be xm minus xl. Only minus xl because it's negative, it's on the wrong side. So we're looking for the distance between them. That will be xm minus xl. So we're going to remove that minus sign effectively. It's going to be 2m plus 3 over m. Oh, and what do you know? That's going to turn into yet another quadratic. So if I multiply everything by m, okay, I can remove this m on the bottom. And then if I move the minus 5m to the other side, I'm going to get 0 is equal to 2m squared. Come on. Oops. No, come on, squares. There we are. 2m squared minus 5m plus 3. Okay, and again, I'm going to have to solve a quadratic. I've done this a dozen times, just in this paper. So we're looking for something that multiplies to give 6 and adds to give minus 5. So if it multiplies to give 6 and adds to give minus 5, I would say that's minus 2 and minus 3, right? So I'm going to split this into a minus 2m and a minus 3m plus 3. So at this point, really, it's insert your favorite way to solve quadratics. And this is how I was taught to do it, so this is the way that I will do it. But it really is up to you. And do you remember from earlier where it said that m is a positive number? It's greater than 0, but it's not 1. Okay, so we actually find that m equals 1 is a solution to this equation. But there's another solution as well. M equals minus 1, m minus 1 here, okay, and you're going to get a minus 3 on the outside of that bracket there. So you can split this down into 2 brackets, either 2m minus 3 in one bracket or m minus 1 in the other bracket, and they each have to, separately they each have to equal 0. But one of these gives the solution m equals 1. That's this bracket here. The other one gives the solution m is equal to 3 over 2. So that will be your answer. Let's see if that's an option. I'm begging you. Is it an option? No, it's not. Must have made a mistake somewhere here then. Okay, where is that mistake? So xm is 2m minus 3. 2m is minus 3 over 2. Oh, I'm looking for m plus p. Ugh, read the question. Read the question. Come on. Okay, so p is minus 1 over m. So flip it and change the sign again. So we can do that by just saying that it's 3 over 2. So this is m plus p. So 3 over 2 is m. P is going to be minus 2 over 3. So if I multiply top and bottom, it's going to be one of the over 6 ones. So let's make that 9 over 6 minus 4 over 6. So that's going to be 5 over 6. Okay, lovely. That's the answer. Nice. Okay, happy about that. So two identical blocks, each of mass m in two different arrangements. Okay, which expression gives the gravitational potential energy of arrangement 2 minus the gravitational potential energy of arrangement 1? Okay, so this is just asking where the centers of mass are. They both have the same mass, which is 2m. Yeah, this arrangement is 2 blocks, this arrangement is 2 blocks, so they're both 2m. But where's the center of mass? And it's really, you just have to look at it, it's symmetry really. So one of them has its center of mass there, which is b above the ground, and the other one has its center of mass here, which is a above the ground. So arrangement 2 actually has less potential energy than arrangement 1, but we're still going to do it that way round, so it's going to be 2mg, so the mass is 2m, times b, and then you're going to take away 2mg times a, because that's, oops, sorry, I've done it the wrong way round, stupid. That one should be a, and the other one should be b. Okay, because this is b high, and this is just a high. Okay. Oh, they asked you to factorize it. So if you did factorize it, it would give you this one. Okay, so arrangement 2 minus arrangement 1. Just checking that's right. Yeah, that looks right to me. Okay, so this is your function. Find a complete set of values for x for which f of x is an increasing function. So if we're looking for when it's an increasing function, we're looking for when the gradient is positive. So if the gradient is positive, we need to differentiate and show that it's going to be positive. Okay, if it's an increasing function, it's going to be greater than or equal to 0. So let me just differentiate this quickly first. So f dash of x, okay, so I'm working out the derivative. That's going to be 3x squared minus a squared, and that's got to be greater than or equal to 0. So what does this curve look like? Well, I would just draw this briefly, just have a little look at what it's going to look like. It's going to cross at minus a squared down here, and it's going to increase. It's going to look basically like, so that's a minus a squared there. It's going to look basically like an x squared graph. It might be a bit steeper, but we need to know these 2 points here where it's crossing. So what we can do is we can rearrange this equation. You don't really need to worry about where these 2 points are, where it crosses, but we can work them out. We're going to work them out by doing this anyway. We're going to end up with x squared is greater than or equal to a squared over 3. And then you're going to square root everything, kind of plus or minus. So where it's greater than 0, where this function is greater than 0 is, oh, I didn't mean to do that, come on, it's really not liking this, is this bit here and this bit here. Okay, so it's above these 2 roots. The 2 roots are going to be x is equal to plus or minus the square root of a squared over 3. So you can kind of take the a squared out and make it just an a, and it's going to be root 3 on the bottom. So it's greater than a over root 3, but less than minus a over root 3. And I think it's a less than or equal to sign, but they don't really give you an option here. So it's going to be greater than, yeah, it's going to be this one here. It's going to be g. Okay. An object is fired vertically upwards from ground at time t equals 0 in still air at a speed of 8 meters per second. On the way up, what is the height of the object above the ground when it has a speed of 2 meters per second, and what time does it reach this height on the way down? Okay, so way up and way down. So we've got I'm going to draw a very brief diagram here. So it's going to be a sort of like that, okay? It's not really a projectile motion. It doesn't really go a little bit to the right, but it's just for demonstration purposes here. So I'm looking for the sort of height when it's at a speed of 2, and then I'm looking for the time when it's at that same height on the other side. So this motion is always sort of symmetrical. So it's going to be at -2 here. Okay, that's going to be the velocity on the other side. So if you're at all worried about that, just think about conservation of energy. Okay, it's at the same height, so it has the same gravitational potential energy, and it just started with kinetic energy, so it must have the same speed, but obviously it's going in the opposite direction, right? So the GPE plus the kinetic energy, the gravitational potential energy plus the kinetic energy must be the same at all times, okay? So it starts with just kinetic, and at all other points it has gravitational and kinetic. Okay, so let's have a look. We're looking for first, what time does it reach this, what height does it reach when it's at 2 meters per second? We can use a Suvat equation for this, so I recommend you memorize these. I'm just going to use the one u plus v over 2 times, oh no, I'm not going to use that one at all. I'm going to be using instead v squared minus u squared over 2a equals s. Okay, so that one gives me my displacement. I've just, I remember it usually as v squared equals u squared plus 2as, but I just rearranged it. So this is 2 squared on the top, which is 4. Its initial velocity is 8, so it's 8 squared. All over 2 times a. A is always taken to be 10 here, so it's all over 20. So it's 4. Oops, have I made that the right way around? Oh, that's going to be a -20, sorry, on the bottom. G. So the acceleration is in the downward direction. I should have really told you which direction was positive, which direction was negative, but acceleration is downwards, and I'm going to take this to be my positive direction. Okay, so I'm going to end up with -60 over -20, which is going to give me a height of 3. Okay, a displacement of 3 upwards. Okay, so 3 are these ones here. Okay, it wants to know the time when I'm at that same height on the way down, so the time from 0. So I'm now going to be using v equals u plus a t. Okay, so I'm looking for t here, and my v is actually going to be -2 because of this sort of symmetry argument. So -2 minus 8 over -10 is equal to my t. I'm just rearranging for t there, so v minus u over a gives you t, and that is just going to be 1, isn't it? It's going to be -10 over -10, so the answer is G. Okay, 45. The curve y equals x squared is translated by a vector 4, 3, and then reflected in the line y equals -1. Which of the following is the equation of the resulting curve? So I would just draw this in steps. So we start with y equals x squared. I assume you guys know what that looks like. Then it translates 4 over to the left, 4 over in the x direction, and 3 upwards. So it's like that. And then it's reflected in the line x equals y equals -1. So this is -1. So that distance there is 4 to the apex, to the minima of this curve. So it's going to be reflected so that the 4 is down here as well. This distance has to be 4, 2. So so that distance has to also be 4. So this sort of position of the minima is going to be at -5, 4. Okay, that's the coordinates of this sorry, at 4, negative 5. Negative 5. So it's negative 5 in the y direction, and it's 4 in the x direction. And that's really how we're going to solve this, because if you know that you can work out the position of the maxima or minima of an x squared graph by completing the square, then you can actually work out where this is quite easily. So the way that usually works is if you have y equals x minus a squared plus b, if you complete the square, then you can say your apex is at, or your minima is at the position a, b. Okay, x is a, y is b. Okay, so just having a bit of trouble here drawing this b. B. Okay, a, b. So we know that we're going to have an x minus 4. Y is going to be minus 5. But here's the thing, this gives you a positive x squared graph, whereas we actually have a negative x squared graph because we sort of reflected it down. So you want one of these equations with a negative in front of the squared bracket, so that rules out quite a few. And then you want the x to be minus 4 and the y to be minus 5. So the only option here is E. Okay, so next question. The diagram shows a ball P of mass 4 kilograms moving to the right with 10 meters per second and a stationary ball Q of 2 kilograms. So this is going to be a collision problem. Immediately after the collision, ball Q moves 10 meters per second to the right. What is the velocity of ball P immediately after the collision, and how much kinetic energy is lost? How much kinetic energy in total is lost during the collision? So the initial momentum is 10 times 4. I'm going to make this my positive direction. I'm going to make this my positive direction. And it's going to be 10 times 4, so it's 40. Okay, so that's my total momentum, 40. And that's got to be equal to the ball Q will move 10 meters per second to the right, so that's going to be 20, and my ball P still has a mass of 4 kilograms, just times a new velocity that I'm just going to call V. So I can work out this new velocity by taking away 20 on both sides and then dividing by 4. So that will give me a velocity of 5 to the, still going to be moving to the right. Okay, so 5 to the right, so it's these two. So initially I have a total kinetic energy of 1/2 times 4 times 10 squared. So 1/2 times 4 is 2, 10 squared is 100, so it will be 200. So initially the kinetic energy was 200, and then after the collision, well, we have 1/2 times 4 is 2 times 5 squared. That will be my kinetic energy of my ball P. So 1/2 times 2 times 5 squared, that's going to be 50. And my ball Q is 2, that's my mass, times 1/2, which is just 1, times 10 squared, so it's just going to be 100. So we started with 200, we end up with 150, so we've lost 50. So the answer is going to be E. Okay. The complete set of values for x for which this is greater than 0, okay, is. So this is a quartic equation, so we're going to need to solve this equation to find the roots. But all quartics, well, all positive quartics anyway, look something like this. Okay, those, sorry, that that should be a sort of W shape, something like this. Not necessarily at the same height, these two minima, or it doesn't really have to have this great symmetry, but yeah, it's going to be a kind of W shape. So we're going to look for the points where it crosses the x-axis, and then when it's greater than 0 is just outside this range and outside this range here. Okay, so let's find those solutions first. What I'm going to do is I'm going to substitute I don't know, any letter. Let's use Z. Z is equal to x squared now. Z, I'm going to make a Z with a little dash so you know it's not 2. Z is equal to x squared. Okay, it's really panicking now. So it's 2z squared minus 9z plus 4 is greater than 0. Okay, fine. So I'm looking for solutions to this equation. Again, I'm going to solve another quadratic. So I need to solve this for z to find out where this is sort of greater than 0. So I'm multiplying to give 8, and I'm adding to give minus 9. So it's going to be, two numbers are going to be minus 8 and minus 1. So it's going to be 2z squared minus 8z minus z plus 4. Okay, that's got to be greater than 0. So if I solve this to find the values of z for which it crosses the axis, those are going to be, so I can factorize out 2z here. Z minus 4. And if I copy that bracket over, this is just going to be z minus 4 again over here. And I'm going to put a minus 1 in front of here. Okay, so my two solutions for z are going to be z is equal to a half and z is equal to 4. Z is equal to 4. So this one actually is going to be a bit symmetrical. So when I sub back in for x squared and square root, this will give me those 4 points that I cross the x-axis, right? And it's going to give me x is equal to plus or minus 1 over root 2, and x is equal to plus or minus 2. Oops, just get that 2 in there, or plus or minus 2. Okay, so if we have a look at what that's going to look like, you have to be a bit careful that you make sure you know these sort of areas that are underneath the curve. So it's going to be in between minus 2 and minus 1 over root 2. That will be one point that it kind of goes below the axis. So it will be kind of under the axis there, and it will then be above the axis for a little while, and at 1 over root 2, it's going to dip below the axis again, and at 2, it's going to rise above the x-axis again. So it's in this range and in this range. Okay, so which answer is that? That is answer D. Okay, a point object of mass 2 kilograms is at rest on a level horizontal surface. The coefficient of friction between the object and the surface is 0.25. Two horizontal forces are at right angles to each other with magnitudes 9 and 12 newtons. They're applied simultaneously to the object. What is the magnitude of the acceleration of the object as it begins to move? So this is kind of a weird one. You're kind of thinking, oh, there are two forces that are at right angles to each other, but it's on a level horizontal plane. So a good drawing of this would be like if the object's on a table and we're looking down on it. Okay, so let's say we're looking down on it, and let's say our, it doesn't really matter which way you decide to do this, but let's say our 12 newtons is pointing up. Okay, 12 newtons is pointing up, and our 9 newtons is pointing to the left, so sort of in the x and the y direction. So if I want to, I can work out the sort of resultant of these two forces by using a force triangle. So I say always look out for these 3, 4, 5 triangles. Here's one here. So the third side of this triangle is going to be 15. And the reason for that is that this is just a 3, 4, 5 triangle multiplied by 3. So 9 is 3 times 3, 12 is 4 times 3, so the third one has got to be 5 times 3. Now, the friction must always oppose this force, so it always opposes motion. So imagine there wasn't friction, it would just move in that direction, so the friction has to point in the opposite direction. And it's of size mu r. So this is an equation you need to know. Friction is the coefficient of friction times the reaction force. Now, we know it doesn't fall through the table, so if we were looking sort of at the table and we looked at the object on the table, I'm sort of drawing it from the side on now, so this is so if that was the y plane, I'm now looking in kind of the xz plane. So I have the weight of my object going down, and the only force that counters that is the reaction force from the table, provided the table isn't made of jelly or something, so it's not going to sink through. So the weight is just 2 times g, so 20. So the reaction force is just 20. And if I put 20 in here and my mu of 0.25, I find my friction force is equal to 5. Okay? So we need to take 5 away from 15 because it acts against that motion. And that gives me a force of 10 acting on a mass of 2. Okay, so a lot of steps here. So my force is 10 acting on a mass of 2. To work out my acceleration, I'm going to use F over m. 10 over 2 is just 5, so the answer is A. Okay, so right, a cursor starts at a point 0, 10 and moves parallel to the x-axis in the negative direction. What is the minimum distance parallel to the y-axis between the cursor and the graph of this? I don't really know what they mean by cursor, but I'm just going to replace that with like object. I suppose they mean kind of like a pointer, like you have on the computer. So this is an x cubed graph, so we know it's going to look something like, well, these are sort of rough positions of where the maxima and minima are going to be, but certainly the maxima is going to be before the minima because this is a positive x cubed graph. We start up here at 10, and it says that we're going to move in this direction, and they're asking for you what's the minimum distance parallel to the y-axis. So what's the minimum distance between the curve and the kind of line that this object travels, this cursor travels. So it's going to be here, it's going to be at this local maxima, I think, unless of course, I mean there is an option of 0, so if the curve actually looks like this, it would be 0, it would cross the line. So we have to sort of think about this. So maybe just to rule out the 0 one, I would see where does it cross the y-axis. So it crosses the y-axis at -15, so somewhere down here. So I think we're going to get a graph that looks something like this. It's certainly not going to be 0, but we need to find this maxima, right? So the only way to do that is to differentiate and set it equal to 0. So we're differentiating to find a gradient function. We'll set that equal to 0. So if we differentiate, we will get 12x squared minus 24x minus 36. I'm going to set that equal to 0. If we set that equal to 0, look, there's a factor of 12 in all of them. So that is going to be just x squared minus 2x minus 3. So something that multiplies to give minus 3 and adds to give minus 2. Very easy. Just x. Oh my god. Okay, so that's equal to 0. And then it's x minus 3. So one solution is x equals 3 and x plus 1. So the x equals 3 solution is going to give my minimum, and my x equals minus 1 is going to give my maximum. So this is minus 1. So I need to work out this like local maxima here. This local maximum, if I put minus 1 into this equation, I'm going to get minus 4, minus 12. Come on. There we are, minus 12, plus 36, minus 15. Okay, so if I do that, I will get 5. Yeah, 5, and we started at 10, so if this maxima is at 5, then the distance is 5, right? So if this happens to be at 5, this maxima, then that distance between 5 and 10 is 5, so the answer is B. Okay, weird, tricky question there with the kind of cursor thing. I don't really know what they were on about there, but you can work it out even if you don't really know what a cursor is, like me. Okay, so what is the frictional force between the object and the plane? So we know that this is in free fall. Well, it's freely falling at 2.5 meters per second. So this is going down at 2.5. And this must be then accelerating up the slope at 2.5. Okay, so it's an acceleration. We know that we've got a weight force here of 200 and a weight force here of 300. So I'm just timesing by 10 to put it into newtons. This is going to have a tension pulling it up. That's why it doesn't just fall at G. There must be a tension here to stop it just falling at G. And that same tension is pulling on the 20 kilogram mass. So we also have, oh, it's a long one, this one. It's got loads of components. We've also got a friction force going down. It's angled at a rough plane. We need to find this friction force. So that's what we're actually looking for, the friction Fr. And that's pretty much all we need. So the first thing we need to know is the tension. If it's falling at 2.5 meters per second, I'm just going to do F equals ma on this 30 kilogram mass. So I'm going to say downwards is my positive direction when considering this mass. So I can say I've got 300 newtons down minus t newtons up is equal to, so that's my F, is equal to 30 times my acceleration, which is 2.5. So on the left here, we're going to have, so that's going to be equal to, so 2.5 times 30, that's, well, times by 2 is 60, and then add a half on is 15, so that's 75. So my tension is equal to 225, okay, just 300 minus 75. So tension is 225. Now, what's useful here is I don't really need to consider the perpendicular direction on the 20 kilogram mass, okay? I just need to consider the parallel direction, parallel to the slope, okay? So if I drew a tiny little force triangle in here, then if I'm going to draw that a little bit bigger to the side here, it would look something like, oh, that's really rubbish. Wait a second. It will look something like this. Okay, so that's my 200 newtons going down. That's the hypotenuse of this triangle. There's the right angle there. This angle here is always going to be the same as the angle of the slope, so that's 30 degrees. Come on, 30 degrees, lovely. So I'm looking for this opposite side. So opposite means sine, so this is going to be 200 sine 30. And you should know sine 30. Sine 30 is a half. So 200 sine 30, so that's just 100 newtons down the slope. And that's all we need. Now we know that it's traveling up the slope at 2.5 meters per second. We can do F equals ma on this. So we've got 225 newtons going up the slope, minus 100 newtons going down the slope, minus our friction. And that is equal to ma, which is 20 times 2.5. 20 times 2.5, that's 50. So that friction force, that's going to be 125, these two here. These two are 125. So minus friction, that friction must be 75. Yeah, 125 minus 75 gives me 50. So that's the answer there, 75. Okay, what is the area enclosed by the line x equals 7 and the curve x equals 3y minus 1 squared plus 4? Right, so this question wouldn't be difficult if the x and the y were like swapped around, really, would it? I mean, we can just swap x for y and then we can use a normal xy graph, okay? So x and y are just labels of variables. In fact, I could do this just by kind of rotating the xy plane. But I'm just going to swap them around because I think I'd feel a little bit more comfortable, and maybe you would too. So I'm going to make this y is equal to 3 x minus 1, x minus 1 squared plus 4. So you're happy to do that. You're free to do that if you wish, okay? And now I can just draw it if I like. So thinking about where the minima is going to be, where the minima of this quadratic is going to be at x equals 1, y equals minus 4. X equals 1, x equals 1, y equals 4. So that's going to be somewhere here. So 1, 4. Okay, so the curve looks something like that. And actually, if you think about it, where is the line x equals 7? It's somewhere over here. And where does it cross the axis on the y? This is not really necessary, but so y equals 7 is up here somewhere, but it's actually also the point where this will cross where it's actually the intercept of this curve. Okay, so 7 is up here. Okay, let me do a 7, please. There you are, 7. So our curve will go something like this, right? Actually, that's not 7 there. I shouldn't have bothered drawing that. Okay, so it's where it crosses this line. So it's not going to be 7 just at one x coordinate. It's going to be 7 at two x coordinates. So when else is this going to be 7? We can sort of solve that by putting in y is 7 into this equation. So if I take away 4 from both sides, that's just going to give 3 is equal to 3x minus 1 squared. So x minus 1 squared is going to equal 1, right? X minus 1 squared is just 1. So x minus 1 is equal to 1 or minus 1, right? I've square rooted. So I'll show you these steps. So we divide by 3 on both sides, and then we square root. So we've got plus or minus 1 equals x. X minus 1. So the other solution here, the other x value, is just going to be 2. Okay, so we're looking for this area under the curve here. Actually, no, we're not. We're not looking for the area under the curve. Well, we're going to need it, but we need this area, right? It's in between y equals x and the curve of y equals... So it's in between this bit here. So it's the bit at the top there. So if we work out this bit, we can take it away from a rectangle with an area of 7 times 2, which is 14. So we just need to do 14 minus the integral of this curve, the integral of y, dx. And that is going to be between, dx, it's going to be between, what are we saying? Between 0 and 2. 0 and 2, and this is 3x squared. 3x squared minus 6x plus 7. 3x squared minus 6x plus 7. Okay, so if we do this, what's it going to become? So the integral of x squared is just x cubed. Of 3x squared is just x cubed. Okay, adding 1 to the power divided by the new power, and then we're going to get a minus 3x squared. So So that's a minus 3x squared. And then it's going to be a plus 7x. Okay, and actually the two sort of roots, the two bounds are 2 and 0. So because all of these have an x in them, the 0 one we don't really need to worry about. We just need to worry about the 2 one. So that's going to be 8 is 2 cubed minus 3 times 4, which is minus 12. So that's minus 4. Okay, that's a minus 4 of those two. Plus 7 times 2 is 14. So minus 4 plus 14 is 10. And that's the result of this integral. So 14 minus 10 is just going to give us 4. So that's option A. Okay, nice. Right, a spacecraft of initial total mass 4,000 kilograms is traveling relative to the Earth at a constant speed of this. It ejects some fuel backwards in a sudden burst at a speed relative to the spacecraft of this. As a result of this, the speed of the spacecraft immediately after the fuel is ejected increases to this. What is the mass of the fuel ejected? Right, so this question you have to think, which frame do I want to solve my problem in? Do I want to solve it in the plane of, which frame do I want to solve this problem in? Do I want to solve it in the frame of the spacecraft or the frame of somebody on Earth watching? And I always think it's easier to do it in the frame where you're stationary. If you're happier doing it in the frame where the observer is moving, that is up to you. Good for you. I prefer to do it in the frame where everyone else is moving and I'm stood still. Okay, so if I'm watching this, I know I start with a mass of 4,000 kilograms that is moving with a speed of this 7 to 5. 7 4. There should be a 4 in there. Sorry, there should be a 4 in there. 7 4 2 5, and then afterwards, you've ejected this mass out the back, and it says that it's moving at a speed backwards of 1425, but relative to the ship. So that means they shot it out the back, and relative to someone on the ship, they would see it move away from them with their speed. Well, they would see it move away from them at 1425, but relative to somebody on the Earth, you would see it still move forward. This is what I call kind of like the case of if you throw something out of your car window, it appears to you to fly backwards, but to somebody watching the car, it would kind of move forwards and kind of bounce along the road, right? So the velocity of this mass that's shot out the back is 6,000 meters per second compared to somebody on the ground, and then your spacecraft starts to move a little bit faster. So we're going to call this a mass m, and this would now have a mass of 4,000 minus m, so we've got to conserve mass. This is no paltry mass when you're talking about spacecraft. In fact, they try and use as light fuel as possible because it's one of their main, it's probably the main weight that they use. Like that when they're taking something up to space, they use more fuel to get there than whatever they're taking up there. It's heavier, it's got more mass. So the velocity of this increases to 7,500. Okay, so we can use conservation of momentum here to solve this problem. So I'm not going to bother sort of calculating the results just yet because I think I can probably sort of factorize this later and make the sums a little bit easier. Oh, sorry. What happened there? Okay, so I'm going to go 4 to 5. Okay, that's equal to 6,000 m plus 7,500 500 times 4,000. Yeah, I can see that I'm going to get another 7,500 times 4,000. I've got a 7,425 times 4,000 on that side. So I can sort of, I don't have to actually work out what these big sums are. I can sort of do them in a minute and sort of make them a bit smaller for myself. So if I take the 7,500 times 4,000 over to the other side, I'm going to be sort of taking that away, right? And that's going to be 4,000 then, just times minus 75, okay? If I take it away from both sides. So you can write this as 4,000 times minus 75, and I'm still not going to actually calculate anything. I don't really like doing calculations, so I'm going to wait till my final chance to stop, to actually calculate something. I've got 6,000 m on this side, but I've also got a minus 7,500 m from opening up that bracket. That's going to be 1,500 m minus 1,500 m. So I can take away a couple of zeros on both sides. That's something I'll do first. And then I can do, let's actually divide by the minus 15. So I've got 40 times minus 75, but minus 75 divided by minus 15 is just 5. So it's 40 times 5, and that's going to be equal to my m. So it's 200. That's the answer. So I didn't have to ever do anything like 4,000 times 7,425, and you shouldn't do that either. Okay, so a curve has this equation. What is the complete set of values for k for which the equation has exactly 4 distinct roots? So this is exactly like the question earlier where I told you that quartic equations had this kind of W shape, right? We had this W shape. And so we're really comparing two equations, y equals this quartic and y equals k. The set of solutions will be where those two lines cross, okay, y equals k. So if we know this height here, and we knew this height here and this height here, where all three of these are, the set of 4 solutions is going to be between these two, right? Any line that goes between these two will have 4 solutions. Any line outside that range will have less solutions, okay, fewer solutions, sorry. So we need to know this y-coordinate and this y-coordinate. There's only one way to really work out the y-coordinates of maxima and minima. That is to differentiate and set that equal to 0. So when I do this, I'm going to get dy dx. I'm going to set it equal to 0. That's going to be 12. Come on, 12x cubed minus 12x squared minus 24x. Okay, so one of my solutions is x equals 0. Okay, that comes from all of the x's. Then I'm going to divide by 12 as well, just to make this a nice quadratic. So it's going to be, x squared minus x minus 2. So the other solutions are at x equals, so I've got to solve this. So they add to minus 1, they multiply to minus 2, so that's going to be x minus 2, x plus 1. So the answers are going to be x equals 2 and x equals minus 1. Okay, so the three solutions, this is minus 1, this is 0, and this is 2. We're not really concerned about the, well, we need to know which one's the lowest, I suppose, because it could be a situation where it dips down this side and then up, then that. So we do really need to know which one of these is the lowest side. So we're going to have to plug these in to find out what the y value is. So at x equals 0, that's the easy one, y equals 20. Okay, at x equals -1, so that's going to be 3 plus 4 minus 12 sorry, plus 20. Okay, so a quick way of doing that is just if it's a odd number on the power, it's going to be a -1. If it's an even number on the power, it's going to be a +1. That's how I always do it. So 7 plus 20 is 27, take away 10 is 17, take away 2 is 15. So this one is y equals 15. And then x equals 2, this is going to be the hard one. So 3 times 16, that's 48. Okay. 4 times 8, that's 32. So we've got 48 minus 32. 48 minus 32. And then the minus 12 times 2 squared, that's going to give me a minus 12, that's going to be a minus 48. So that's going to cancel out with my other 48. And then I've got a plus 20. So the answer for that one is going to be minus 12. Y is minus 12. Okay, minus 12. Okay, so what does this really look like? Well, the 0 solution is up at 20, so it goes, the -1 solution is minus 12, the 2 solution is up at 15. So I think the answer is going to be, it looks kind of more like this one here, and this is 20, that's 15. So if you want 3 solutions, it's got to go in between those two. So it's this one, C. Okay, last question. An object of weight 40 newtons hangs from the end of a light inextensible string of length 0.35 meters. Okay, a constant horizontal force of 30 newtons is applied. Oh, I can see a 40 and a 30. That makes me feel like the other force might be 50, 3, 4, 5 triangle, causing it to move to a new equilibrium position with the string no longer vertical. By how much has the gravitational potential energy of the object increased as a result of this change in position? So let's sort of draw this one, shall we? So I've got a mass. It's got a 40 Newton force, weight going down. I've applied 30 newtons to it here. And what I really need to work out is this angle. Okay, if I can work out that angle, I can really sort it out. Okay, so let me just get rid of that. Okay, so if I can work out the angle to the vertical here, I'm going to call that alpha. Okay, so I can actually work out this force here. That is, I think, going to be 50 newtons because it's again a 3, 4, 5 triangle. If we just think about this triangle for a second, we can say we've got a tension that is going up at the angle alpha. Okay, and that points in that direction. Then the 30 newtons takes it back, and the 40 newtons points down. So this is actually a object in equilibrium. So this vector triangle of forces should end at the point it started. Okay, so the tension pulls you diagonally up to the left, and then the force that you're pushing it with, the 30 newtons, pushes you to the right, and the 40 newtons pushes you down. So this is a 3, 4, 5 triangle. This is your right angle. So that's your right angle there. Okay. So if we want to know this angle alpha, it's quite easy to work out that angle alpha, but we don't really need to work out the angle. We could actually use the fact that we can use the definition of sine and cosine as like the SOHCAHTOA. Sine is opposite over adjacent. So But what do we actually want to work out? We want to work out this new height. Okay, so we want to work out this distance from the ceiling, because it used to be that it hung at 0.35 meters. Now, whatever this new height is here, is our new height. So we want to work out this change in height so that we can then use weight times change in height is equal to change in gravitational potential energy. So we're going to be using, if you look at this triangle with the alpha in it, I'm going to be using cos alpha. Okay, so the length of the string is 0.35, so the hypotenuse is 0.35. So we're going to be using 0.35 cos alpha. Okay, so 0.35 cos alpha, and you can use the vector triangle here to work out exactly what cos alpha is. So cos alpha from this triangle, the adjacent is the 40. Oops, that's the adjacent. This is the hypotenuse, the 50. So it's quite simple to work it out. It's going to be 40 over 50. So height, so 40 over 50. So 0.35 times 40 over 50 times 4 over 5. 4 over 5, we could divide by 5, so that would be 0.07 if we divided by 5, and then times by 4, that's going to be 0.28. So it's actually gone up a height of 7 centimeters. Okay, so we're just going to use weight times that change in height. So we know this is now, just to be clear, just give me a second, this is now 0.28, so it's gone up 0.07 meters. Sorry about the running out of space here. So if we do the weight times that change in height, we will work out the change in gravitational potential energy. So the weight is 40 times 0.07. Well, I know it's going to be something 28 or 228, right? There's only one option there that has that. It's going to be B, 2.8 joules. Okay, so that is a full solution to section 1 of the engineering admissions assessment for Cambridge. Thank you for listening. I'll have more solutions for you soon. Thanks.